This video is going to be about states of matter. We're going to talk about the different states of matter. We're going to look at the three common states, and we're going to also talk about how the particles in those states interact. So before we can look at mixing matter, we need to understand states of matter. Because remember, the end goal of this lesson is to talk about us mixing different forms of matter. Okay, we need to talk about the states of matter, that the different states that they're found in, and what's actually happening to each particle. So just to recap, the three states of matter that you should be familiar with are a solid over there, a liquid, and a gas. Okay, so solid, liquid, and gas. Now we're going to talk about the particles in each one of them, but first I want to talk about water. Here we have water in its three different states of matter. Okay, and I want to talk about what the particles look like in each one of those states. So if you use your imagination, this is what a particle looks like. If you look at the camera in the bottom there, this is what a particle looks like in a block of ice. So if you picture this as a water particle or an atom of water, this is what it looks like when it's in frozen state. And this ball over here is what it looks like when it's in liquid state. And this ball is what it looks like when it's in gaseous state or gas. Okay, they're all the same. And that's what I want you boys to take away from the first bit, is the particles themselves, the atoms that make up something don't change when it's liquid, solid, or gas. They all remain the same. Water, no matter which state it is, if it's solid, liquid, or gas, does not change. The particles are the same, but the way they interact is what's different, okay? So particles in a solid are not harder, and then particles in a liquid aren't softer. That's not how it works. They're all the exact same, okay? The only difference is how they interact. So if you look at my screen here I've got a little GIF of particles, and this is particles in a solid. So the first thing you need to know about all particles, not just solid particles, but all particles, is that all particles are moving around constantly. These little atoms that make up everything, they're always moving. They cannot stop. They're just all over the place, okay? So that's the first thing you need to know. Whether it's a liquid, a solid, or a gas, the atoms or the particles inside of it are moving all the time, okay? In a solid, the particles are held together very tightly. So what that means is, in a solid, you got this particle in a solid and this particle, and they're holding each other together so tightly, okay? They can't get away from each other. No matter how hard they try, they keep getting pulled back to each other, okay? So in a solid, the particles are held together very tightly. So when they move, they just vibrate back and forth. So remember, particles are moving the whole time. They just want to move around. They want to buzz around the whole time, okay? But in a solid, there are other particles that are holding it in place. So this particle wants to buzz around, but his friend over here is holding him in place. So he keeps pulling away and then get pulled back, push, pull, push, pull, push, pull, and eventually he's just bouncing back and forth. And this one's doing the same. They're both trying to get away from each other, but they're also both pulling each other back. So they're vibrating back and forth, but they stay in place like this, okay? They stay in place the whole time. And that's what's happening in a solid. Okay, now that might be a bit confusing, but maybe it makes a bit more sense when you look at a liquid. Here is an example of atoms in a liquid. Now, in a liquid, the atoms aren't held so tightly as they are in a solid. They can actually move around a bit more. So they're still pulling each other, so they can't escape completely, but they're still pulling each other. But they're a little weaker. So this atom doesn't vibrate back and forth. He shoots up, he shoots there. He's able to move around the other one, and they sort of move around each other, okay? So in a liquid, the force of attraction between the particles is not as strong as in a solid. So the particles move around each other. So that force holding them together isn't as strong. So the particles are actually able to glide past each other. They're actually able to pull apart and come around and change shape. And that's the reason liquids are actually able to flow. Because in a solid, if this is my solid, it's always going to stay in a triangle shape because these particles are holding each other together like that, okay? They can't escape. But in a liquid, they can change their shape. So if I took a liquid and I poured it out, they'd move away from each other, they'd move out, they'd splash around. So they're able to move. They don't keep their shape like a solid does. All right. Then we have the particles in a gas, and they're just going crazy like this. Hopefully you figured out the pattern. Solid, they're really being held close together. Liquid, they're being held very weakly together. Gas, they really don't hold each other together at all. They just bounce around. Bing, 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 bing. Okay, so gas is they're always moving around. All right, so in a gas, the particles are able to move around freely and spread out from each other. So there's no force of attraction holding them. So a nice way to think about this, or not a nice way, but a way that I think boys often seem to resonate with or understand best, is a fart. So a fart is a gas. Now, gases, so if you think of somebody farting in a class, that's a gas. It all starts in one location where that person is, but because the particles in that gas aren't being held together, it spreads out throughout the whole class. And that's why it starts at one point, but the smell spreads out in all directions, okay? Because the atoms inside that gas aren't being held together. It's gross, but it does help you remember it. Okay, so boys, hopefully what you're able to do now is you'll be able to, better than before, describe how the particles in a solid, liquid, and gas are behaving. And I also hope that you know that the particles themselves, they don't change. They're always the exact same. It's just their force of attraction changes, so their ability to move around changes. Sometimes they can move more, sometimes they can move less. All right, let me know if you have any questions. Thanks.